All right, let's do another one of these problems. It says, given that cosecant of t is 5 over 4 for an angle t between pi over 2 and pi, use an appropriate identity to find the value of cotangent t. All right, so we're given information about cosecant, and we want to find the value of cotangent, so that means we're going to use something that relates to two of them, perhaps the Pythagorean identity that relates to two of them. All right, but before we do that, let's set up where on the unit circle we're working. Okay, so given that cosecant t is 5 over 4 for an angle between pi over 2 and pi, so let's talk about what quadrant that's going to be in. All right, so this is 0, pi over 2, pi, and 3 pi over 2. So what quadrant is our t going to be in? It's going to be somewhere over here in quadrant 2. All right, so let's talk about what we know about quadrant 2. We know that x is negative, but y is positive. All right, so we're going to use this at the end of the problem to help us solve it. All right, so now we're going to use an appropriate identity to find cotangent when we know cosecant. So this is the one that we're using. 1 plus cotangent of t squared equals cosecant of t squared. Okay, and the thing we know is cosecant. So cosecant is 5 over 4. Okay, I'm going to go ahead and square this. Subtract the 1 on both sides. I'm going to write it as 16 over 16 because I already know I want to add them. Okay, 25 minus 16 is 9. So cotangent of t squared is 9 over 16. All right, we're going to have to take the square root of both sides to be able to solve, remembering that cotangent could be positive or negative. So cotangent of t is going to be plus or minus the square root of 9 over 16, which is plus or minus 3 over 4. Okay. All right, so let's remember the thing we know we have to determine, is it positive or is it negative? All right, so let's write cotangent in terms of what it is. So remember, cotangent is cosine over sine. Cosine is x, sine is y. All right, so cotangent is given by x over y. We have to determine if if our answer is positive or negative. Well, what do we know? In quadrant 2, x is negative and y is positive. And negative divided by positive is positive. All right, so that means cotangent of t is going to be positive. Oh, sorry, did I say positive? Negative divided by positive is negative. So cotangent of t is negative 3 over 4. Okay? All right, let's look at number 7. Given a real number t, express sine of t in terms of cosine of t. Well, do we have any equations that relate sine and cosine to each other? We do. Pythagorean identity. So this is the main one. This is the one you need to know the most. All right, so sine of t squared plus cosine of t squared equals 1. And our goal is to write sine of t in terms of cosine of t, which means we want sine of t equals. And our answer will have cosine in it. So I'm going to move cosine t squared to the other side. All right, now our only goal is to solve for sine of t. So we need to take the square root, remembering it could be plus or minus. All right, and that is all. We have rewritten sine of t in terms of cosine. All right, so now let's move on to a topic we've learned before. Even and odd functions. We remember this, right? So remember, a function is even if, so maybe I'll remind us, a function is even if f of negative x is the same as the function, and it's odd if f of negative x is the same as negative of the function. All right, do we remember this? Okay, so our trig functions can be classified into even or odd. And cosine is an even function. So cosine and secant, they're reciprocals of each other, so they're both even. Sine, tangent, cosecant, and cotangent are odd functions. All right, so let's talk about how this could possibly be helpful to us. It says use the unit circle to find the value of cosine of 2 pi over 3 and odd trig functions to find the value of cosine of negative 2 pi over 3. All right, so we want to bring out our unit circle again and find 2 pi over 3. It is right here. Okay, and so our question is, what is cosine of 2 pi over 3? Well, we just want the x value here. It's negative 1/2. Okay, so then we can now understand cosine of negative 2 pi over 3 just by using the fact that cosine is an even function. So in the past, we would see, oh, negative 2 pi over 3 is not on the unit circle. I'm going to have to add 2 pi, find a coterminal angle, figure out what that trig function will be. But here, I'm working with an even function cosine. I know that when I plug a negative into my angle, it's just as if I did not plug in the negative at all. So cosine of negative 2 pi over 3 is the same thing as cosine of 2 pi over 3 because cosine is an even function. And so it's also 1/2. So just by knowing this, you don't have to do extra work. All right. Trig functions also have properties, meaning that they also are periodic, and a periodic function just means it repeats. All right. So our trig functions repeat, and we know this is true because of how the unit circle works. All right. So periodic properties for sine and cosine. If you add 2 pi to an angle and take sine of it, it's going to be the same as if you did not add 2 pi at all. Same for sine and cosine. And we can see this being true using our unit circle, right? Sine of pi over 6 is 1/2. Well, if I add 2 pi, I get right back here again. So sine of 2 pi plus pi over 6 is also 1/2. All right, so the period of sine and cosine is 2 pi. Tangent and cotangent actually repeat after pi. All right, so tangent and cotangent, they repeat much quicker, so after only pi. So the period of tangent and cotangent is pi. All right, and in fact, we can use any multiple of pi or 2 pi to talk about periodic properties of our functions, but I'll do an example in the next video.